Hi, everyone. Thanks for coming for this session. I know the attendance is very low, but we can understand. Many sessions are going at the same time. But let's enjoy it. Let's have a conversation. So what I'm going to cover today is basically, as you see, a concept called network slicing. That'll become more relevant and more important in the context of 5G networks. So I'm going to cover some business aspects as well as some technical aspects, followed by some operator challenges, also what's happening in the industry. So it's all come together. If you have more questions, want to have some deep dive conversation, Ericsson has a booth, P1, as soon as you enter the hall, that's the first booth. So we have two demos. The first one is network slicing for 5G networks, exactly the same name. The second one is NFE and SDN analytics. So both I'll be there, some of our experts also will be there. We can have a lot of conversation there. So you're please more than welcome there. I want to start with what's happening in the industry. You could see the pace of change that's taken place, that will take place. It took nearly about 100 years to connect a billion places or a billion phones, basically a fixed network. Then it took just merely 5 years to connect 5 billion devices, predominantly mobile phones. We also expect by 2020, there will be about 26 billion connected devices, basically Internet of Things, connecting cars, the transport industry, all sorts of things, what we call Internet of Things. We also well on the way towards our original vision of 50 billion connected devices. So what I'm saying is you can see the landscape, what's happening, right? So people to people, things to things, people to things will be communicating, all of us. So that'll have an impact on the network. We'll see how it is and how the network slicing will play a role. Before I go further, I'm sure many of you probably already aware what is 5G, but I also want to chat a little bit about it, including myself a few years back, and many of us thought, what is 5G? Okay, we thought 5G, okay, 5G is upgrade of 4G. You have the radio technology, I go to 5G, maybe some extra spectrum, extra bandwidth, more 1 GB download speed, whatever, right? But 5G is not that alone. It's partially right, that concept, but 5G is much more than that. It includes access, the exact definition access, the transport, and the cloud. So the whole enchilada is 5G. The important thing in 5G compared to 4G, in 5G, the network will be, in a way, it can deliver services for the new industries, what we call network society or many vertical industries. There are a lot of business opportunities for the operator this will create. The most importantly, there will be impacts on the network. That's what I'm going to cover. How can you deliver the services using the current network? For example, as I told, new business opportunities. Also the key part, to deliver new services, the new business opportunities, the network must be very agile. Not only the network, the 5G also includes how do you transform your OSS BSS system. That's very critical. Many operators tell me, okay, it is great. I will transform, I will make my network SDN enabled. I'll make my NFE transformation pretty good. I'll take my mobile core to the cloud, but I have still legacy OSS BSS system. So you cannot deliver faster time to market if you have a legacy OSS BSS system. That should be nimble, should be also agile. So it's a business processes and the technical processes, so operational processes should work together to deliver that. That's what the 5G is. So it's enabling industry and society transformation. The next is, I just explained what is 5G. I also want to touch upon challenges, right, in 5G. So what are the critical challenges in 5G? As I just explained, complex services, right? There could be many challenges. I just named like top 3. For example, take services, right? You want to deliver services to certain industry, vertical sector, car industry or a transport industry, maybe a nuclear industry. The latency may be very critical, very low latency for certain industry. It's a must. Some industry wants to have a very high security, so that's also another thing. Then some industry needs very high bandwidth, sudden, dynamic scale. You just need to have a high scalable network, and then you can shrink it down. So there are different requirements in these complex services. I have one slide where I'll talk about few services. The next one is agility. So I explained that right at the beginning. So agility comes not only your network, okay, you make an SDN, make the network SDN enabled, that gives programmability, service abstraction, all of that, and the agility. But what about OSS BSS? So if I place an order, my OSS BSS system takes the order. From there, designing the service for the new industry, as well as connected to the building system, and then delivering the services, making fulfillment, activate the service. All of this has to be part of the time to market should be very, very fast. Maybe 15 minutes I want to deliver a service. In 10 minutes, not 3, 4 months or 6 months to design, activate, or deliver the services. So agility is that, very important in a new industry, in part of the 5G. Obviously, we want to deliver all of that at a minimum cost as possible. Always there is a cost constraint. So these are the challenges for the operators, or for any industry is going to be part of this journey. To deliver that, to meet those challenges, the networks ought to be enabled, should be highly automated, highly programmable, modular in nature, and also finally the network slice we talk about. This whole presentation is about that. So I'll cover that a little bit more. Here's an interesting thing. I always like this slide. From the developer community, from the technical people, we always want to get into the nitty-gritty of the details, from the code and everything. But end of the day, it's a business value. We all want to make money. So that's the key part. End of the day, that's what it is. Here is an example. What I want to say is, it's not future. It's already there. So network function virtualization journey has already started, right? These are the real examples working in different vertical industry. Different operators are providing these services. Take at the bottom right-hand corner, what do you see there? You see some guy with some little plants there. It's basically a German wine industry. So this guy is touching actual sensor. So the storyline there is, this company came to by the way, the industry also will be a little bit different. In this case, there is a company, Internet of Things company called myOmega. So he's the one as a prime integrator, actually collaborating with other vendors. Ericsson is one of them. There's an operator and that company together to deliver services. You see, there's a lot of collaboration will take place, not just the operator delivering services alone. So in this case, Ericsson has provided, basically what it is they place that wine industry, that wine company wants to have, they have a lot of waste. They want to produce the best wine possible at a low cost, as well as cheaper prices. Sorry, low cost and also environmentally friendly. So what they have done is they placed sensors at a precise locations. That's all designed by this company. And then what the sensor does is it collects the air temperature, humidity, then the soil temperature, soil humidity, and also the solar intensity. All of this information is fed through the telecom network, goes to the cloud, and there's an analytics system in the cloud that actually correlates and analyzes the data. There's the machine learning, and then provides the winemaker exact time to harvest the grapes. So that means he will save money. Grapes are at the best quality at that point in time, and also less waste, environmentally friendly. So you could see how this 5G in this industry and society, how the telecommunication network is helping that industry. It was never possible. We are not even near the picture, right? So in this case, Ericsson provides what we call a device connectivity management and also security. We provide that. And then Telenor company provides the connectivity. And then myOmega is the one, they provide the IoT gateway, the analytics, all of that. That's a typical example. So you could see how the industry will revolve around, different industry will come together. Actually, they innovate new services. The whole supply chain will change now because of these things. And obviously, we want to be together and make money. There's another example that the mining industry also solved the problem as well, right, at the same time. It improves our way of life. So mining industry, usually they move around the mines all the time. So I cannot, once the order comes, I cannot be waiting, create a beautiful network, wait for 3 months. It doesn't work it out, cut it out for them. So in that case, the company there for that provided the service. Ericsson was part of that. And what they do is temporarily create a mobile network and then decommission it, and the mine moves to a different location. This is for the communication between the machines, communication between the mine, very important communication, very safe communication need to take place. There is another case. I won't cover all of it because of the time. In the middle and the top, you see the beach. That's Caribbean. But that company operator has to provide services to different islands, very sparsely populated. I cannot be installing $2, $3 million, $10 million mobile core and network for the 100 people, for example. So they asked us to have the mobile core, what we call EPC, in a box. That's the whole mobile core, enhanced packet EPC. So we provided that. So it's part of the network slicing. So I'm just showing an examples, real-life examples of what's happening. Okay. So we talked about the business. Now let's get into the little bit details. So to provide such a wide variety of use cases that I just mentioned, also future use cases, the network slicing will come into play. We have the current network, so we have to logically, the physical network has to be logically divided to deliver the services. One network, but multiple industries, right? We have seen the logical separation of the network. If you work in IP world, virtual VPN is a logical separation of the network. But here, under the context of 5G, we're talking a totally new level of the separation of the network slice. It's totally new level than we're just talking about virtual VPN service, for example. Here, your whole network, your access, the transport, the core network, everything is logically separated, by the way, including the OSS/BSS system. If I'm a service provider, the expectation from me to the vertical industry, they want the whole thing as a slice, including OSS/BSS. That's it. So the separation is totally a new level as part of the network slicing. This is the Open Daylight Conference. We have to talk about SDN a lot. So the SDN plays a key role. SDN is not just alone you can sell like that, okay, it is SDN. It's an enabler of many things. In this case, it's an enabler of, for example, you want to connect in the mobile core VNF. So it actually dynamically helps to connect the VNFs, different VNFs. So VNFs could be in virtual machines, or it could be in a containerized form, doesn't matter. It's basically intra-DC data center connectivity. The controller helps to set up those connections. And also the WAN, the wide area network between the data centers. So transport connectivity, also important, so SDN helps. Then we go to the service chain. Okay, you set up the basic connectivity, but within the network slice, I may have a different, remember we talked about different use cases. They have a different service requirements, latency, low latency, maybe security. So you have to service chain, you have to steer the traffic to certain areas of the network, right, for certain functions. The service chaining helps. These are the modules you probably know, many of you, SFC, all of that, but I just want to show you how where it is used. Then the scalability is very critical because there are certain requirements. We need suddenly scale up and suddenly scale down. Scalability is not just for the VNFs, through a bunch of VMs. Scalability is also for networking, both the wide area networking and the intra-data center networking. So that's key. Okay. Now we're talking about, this one is 5G ready core. Here we talked about, I talked about SDN. Now, to have the network slicing for 5G, there are several steps. First of all, the networks needs to be, the VNF needs to be virtualized. The network needs to be SDN enabled. And also what I call distributed cloud. Some of the functions, depending on the use case, operator policies, they will go to the central data center. Sometimes you have to take some of your virtual functions very close to the user, end user in a distributed data center. So all these things will happen. And finally, it's network slicing, right? But to do the lifecycle management, creation and management of network slicing, you need the top layer more than ever. That's management, orchestration, analytics, and policy and control, right? You need that layer. Okay. Here, basically, I'm talking about end-to-end proposition. Here you have the physical resources, and then out of that, we'll make logical resources. Then you have also sort of network resources. As I told you, the OSS, BSS itself, network resources here, bunch of network function, access, transport, and cloud. Now we'll use the business layer and network governance layer will actually create and manage the network slice itself. So we'll talk about it a little bit. I'll just speed up a little bit due to time. But to understand the concept of network slice, this is a good slide to understand. I want to spend a little bit of time on this. The next generation mobile network has explained certain set of terms that will be very helpful to know what is network slicing. The middle layer is the network slice itself. So that network slice is created to deliver services for one company, right? Like we talked about the wine industry. That network slice will consist of a bunch of network function, logical resources, physical resources. That's the network slice. As you see here, you have many network slices. But important to note here, each network slice is associated, connected with a service instance, many of that. But sometimes one network slice also delivers services to two different services, could be two different companies. That multiplication or multiplexing of two services into one network slice or not, that's really an operator's policy decision. Maybe they can start with multiplex, two services for one network slice. And the traffic grows up, customer wants, demand changes, they could change that. It's all dynamically possible. That's the beauty of that. Then also we talk sub-network slice. You see the yellow one, a sub-network slice, for example, could be a virtual EPC is a sub-network. We will create many sub-networks. Now that particular sub-network can support different network slices. That's possible as well. Then obviously on the top, I talked about service instance, basically delivering services, business services to an end user or a company. Below, obviously, you have the whole network, including virtual, physical, network function, all of that. That's in a sense the logic of network slicing. This is the governance model, basically from the business, operational, delivering the network slice. The key area, two key things here, network as a service governance and also the network slice governance. The network as a service, what I call is basically a business governance. So you have your OSS, BSS billing system, right? And you basically, customer places an order to me. I design the service. What are all the critical requirements for the service? And then I define that. Also, there is a design and verification tools are needed even in that area. This is all for business processes, right? The next level is the network slice governance. This is where the actual slice, this is a very active layer. That's where the actual slice will be created. The first step is creation of the blueprint itself. The blueprint is nothing but a template that has all the ingredients, basically mobile network, virtual EP, everything. We can explain very well in our demo we can show the blueprint. Also, it includes how the network slice itself will be created, workflows. All of this is part of the blueprint. So a blueprint is actually to deliver say, mobile broadband service to a specific industry. That's a blueprint. Obviously, there are tools required to create that blueprint. You could see that's part of the network slice governance. Once you have the blueprint, you expose that blueprint to the business layer, right? So business layer, first of all, business layer gets the offers, meaning the offer comes from the customer, hey, I need that. So the network as a service, governance layer will look at the blueprint. Okay, this is the right blueprint for me to deliver this particular offer. And then it will change some parameters depending on the service request, sends back to the network slice governance layer, which will go back and execute. If you see at the bottom, that's the whole network. You have the access domain management, the whole radio access could be fixed access, You have the transport, which includes SDN as well, the whole transport network, and also the cloud, the data center, the VNFs management. So the network governance layer will talk to all of these layers to set up the whole slice. And also lifecycle management of the slice, that's critical. Cradle to grave of the service, right? So this is an interesting thing. In this new area, there are many flexibility. So you could see there are two areas. I could get a lot of flexibility out of my business layer. I also get flexibility from my network layer. So the network layer is operationally flexible. The business layer, business-wise flexible, right? Operationally, for example, I could, different features, different functions, right? I can deliver. Characteristics, low latency, high bandwidth, extremely secure, different characteristics. Distribution, distributed data center, central data center. Isolation and sharing, important. Again, security between the network slice. Connectivity, scale. These are the different operational characteristics, right? That the network governance layer provides that flexibility. Business layer, obviously, different business require different service level agreement. That's another flexibility. Billing system and different business models. So those are the two different flexibilities we get from both the layers. Okay, there's another story here, which is dynamic. So again, dynamicity is very important. So in this case, so we created a mobile broadband slice. Users are connected, it's working, but it's monitored. We monitored. Remember, lifecycle management of the network slice. So there are maybe that mobile broadband slice is not delivering SLA that is intended for. So what we do is we get information from the network, apply the analytics tool. Based on that, we could take action. Okay, there is SLA deviation. So what we can do is this all dynamically can be done based on operator policies. So you can create a dedicated network slice, move all the users here and the traffic to the new slice. It's almost impossible to do such a thing today. So that's what allows to do those things. So you can create a dynamic network slice in maybe 15 minutes or half an hour, something like that, depending on the size of the network. Well, I won't cover a lot about this slide. This is the products that we deliver. You can see all of that I explained now, it's there. We'll explain a lot at the demo center. At our Ericsson booth P1. It's the first demo called network slicing. Well, 2 more slides to go. So basically, I want to conclude saying this. There are a lot of numbers out there. Many analysts have different numbers. I cannot predict, neither you guys. It's hard to predict how the industry will evolve, where we go from here. One of the analysts, there is one number they predicted, $1.9 trillion. This is basically a perceived or a predicted value that ICT industry will bring across this various sector. It's a big ecosystem. It's a large number. I think we need to get some chunk of that numbers for telecom industry for us. So connectivity is the main enabler. So for example, connecting, the mobile network slice is also, making, connectivity for different, services and different companies. Not only connectivity. If I'm an operator, I can just be a connectivity provider. Well, I may make some money out of that. But, I just also want to grow. I want to grow my top line growth. This is an opportunity, 5G, that's going to give me that ability to go further. So just being a connectivity provider, I can be the one. We saw an example like my Omega, collaborating with 3-4 companies, 3-4 industries, delivering a single service to the end user. It's a whole new supply chain of delivery where we can make some money. So it's beyond, you can be connectivity provider or you could be the whole solution provider. It's a great opportunity. In summary, so network slicing is a catalyst for the ICT transformation, one of the major catalysts. Obviously, that is enabled by SDN, NFE, all of that. The service agility, network agility are very critical. The most important here is for the service provider. They can be in a connectivity business or they could actually get into a solution business where you can deliver end-to-end services for a different industry. I think that is the biggest point in this. So we see a tremendous possibility for the telecom sector because of this, the 5G. So hopefully we'll see next few years how this will transform. So there's a great potential. So we're just learning as we progress on this. Thank you, guys. Yeah, please. I'm sorry. If I have a time, do I have a time? Okay, I'll take 1, 2, whatever. Yeah. Who's first? Okay.
I was speaking first. Okay. What is the role of open source and open standards like 3GPP and some other SDO in making this happen? And are they relevant? Open source is definitely relevant. The question is the timeline or time frame for open standards like 3GPP evolve the 4G architecture to make it 5G ready. Could you elaborate on that?
Yeah, I mean, it's a very complex question, of course, because we're now connecting the things which very, very deep under the hoods to the dashboard. Exactly. So yes, obviously I was telling the different functionality. That's what we do upstream. Ericsson being a large contributor, you probably know, to the open daylight. That's what we talk to our guys. We need all of this for 5G. You're making something that's part of the agility and what do you call DevOps, right? We have a business model. For that business model, I want to deliver. The coding people should know what is important, and new features have to be developed, whether you say whether NetConf or OpenFlow, whatever they are in OpenStack, to deliver, end of the day, to deliver this growing industry, new industry. That is the whole thing. And also SDN, for example, not only for the connectivity area or the intra-data center connectivity. SDN will have a major use as well. We never touched a lot. Enterprise. Enterprises will start using it. It's a big money-making place where we can actually meet their needs, the enterprise needs actually, not just the operator needs, the final enterprise needs.
How many controllers do you have? Because you have
Say again?
many networks.
Sorry, say again?
How many controllers do you have?
Oh.
Because you have access network,
Yes.
you have metro, you have like a TSDN, transport network.
Sure.
So how many controllers you have? This is the first one. Second one is you distributed this when you deploy it. If you have multiple controller, because each controller probably the network is physical network is totally different. So you distributed it to deploy it, or just centralized, just like the one.
Okay, very good question. So I'll summarize it. So what you're saying, what you're asking me is there different controllers for different segments of the network, and also will you centralize the controllers? Thank you. So basically, obviously, you can have a controller to, for example, take access. If you are dividing access network into a data plane and controllers, there is a controller, of course. Then also on the transport side, that's what we're talking, transport SDN, there is a controller. And then also on the cloud side, cloud networking, there is a controller on the data plane. Data plane could be FIDO, or it could be OVS, whatever, right? But to connect all the dots, that's the whole equation. That's where the orchestration comes in, whether it is a NFEO orchestration or a SDN orchestration or a cross-domain orchestration together. So that's what I talked about, orchestration end-to-end. That also includes the analytics tool as well, because you need to have a closed loop. So that's the whole equation should work together in a dynamic way, zero touch. That is what 5G expects. Yeah. Okay, if there is no question, thank you guys. I also should be worried about my other colleagues next.